Welcome to First Law of Thermodynamics with Ma'am T. This is the third video we are doing on heat and thermodynamics. I think by now you understand or have a clear picture of what thermodynamics is all about. So today we'll be focusing on the first law. There is a second law of thermodynamics, but you are not covering it. So let's look at this. The first law of thermodynamics states that if heat energy Q is given to a system, it can be used in two ways. One, in increasing the internal energy of the system. Two, in doing work against external pressures. That's what the law is saying. So the mathematical expression of this law you're going to find it in your formula sheet. Let's explain what it says. It says heat that is given to a system can be used in two ways. By increasing the internal energy of the system and also by doing work against external pressures. That's what it says. So let's break this down. So what is it saying? It says that if I have a system, I am doing what? I am adding the heat. So heat is Q. It is going to be positive because I'm adding it. It's endothermic. This heat that I'm adding to a system can be utilized in two ways. It can be utilized in increasing the internal energy of the system, and it can also be utilized in doing work against external pressures. That's what the law is saying. As easy as that. So it's up to you whether you're going to have an understanding of what the law is saying or you're going to memorize it from the formula. I don't expect anyone to get this thing wrong because it's easy. Heat is given to a system. It can be used in two ways. One way, in increasing the internal energy of the system and also doing work against what? Against external pressures. That is what the first law of thermodynamics states. It's easy peasy. Now, let's understand what is internal energy. Internal energy is defined as the sum of kinetic and potential energies of all the molecules of the system. That is what is called internal energy. I think you remember what kinetic and potential energy is from grade 10. So they're saying that internal energy can either be increased or it can be decreased. So when we increase the internal energy, we are doing what? They're saying we are transferring heat from an external source to the system. So it means that if I have a system and I'm adding heat to the system, the heat is positive. By doing that, I am increasing the internal energy of a system. We all know if I am cold, I need to get myself warm. I have to increase the internal energy of my body. I am going to do what? I am going to put in heat. I'm going to keep myself warm. I'm going to make myself warm either by wearing warm clothes or by sitting next to a fire or a heater so that I can absorb the heat. By doing so, I increase the internal energy of my body. Another way we can increase the internal energy of a system is by performing work by exerting an external force on the system. So that simply means what? Exerting an external force on the system, it simply means what? The surrounding will be the one that is doing the work on the system. So if the surrounding does the work on the system, we are saying that the internal energy is going to increase. So the work that is done by the system, by the surrounding on the system, is said to be negative. In the same way that internal energy can be increased, it can also be decreased. So it's always going to be the opposite. So we said that it can be increased when we do what? When we add heat to the system from an outside source. Now in this regard, because we want to decrease it, it means the system now has to do what? Now has to lose the heat to the surrounding. So that is going to be Q minus. And a way in which a system can lose heat to the surrounding is because it's going to do what? The system will now be doing the work on the surrounding. And the work is going to be positive. If the system does the work is positive. And if it's the surrounding that does the work, the work is going to be negative. So if heat is added and work is done by the surrounding, then the internal energy, delta U, is going to increase. But if the work is done by the system on the surrounding, and the system is losing the heat when it's doing the work, then the internal energy is going to decrease. Example 1. 450 kilojoules of heat energy is supplied to a certain machine. 275 kilojoules of this energy is converted to mechanical work. Calculate the change in internal energy of the machine. Let's break it down. I have a machine. They're saying what? They're supplying it with heat of how much? 450 kilojoules. And they're saying what? Some of it, 275 kilojoules of it, is converted into mechanical work. So the machine is going to be the one that is doing the work on the surrounding. So work is going to be a positive, right? 275 kilojoules. The heat is being absorbed, so it is also going to be positive. Now we have to calculate the change in internal energy. They want us to find delta U. This is easy. The formula is given in the formula sheet. Q is equals to delta U plus W. How much is the Q? Be careful. It's given in kilojoules. The heat is given in kilojoules. The work is given in kilojoules. So because they are the same, I don't really have to convert. But if they were not the same, I was going to have to convert. So let's just convert so we can know what to do. So it's going to be 450 times 10 to the power 3 is equals to delta U plus how much? 275 times 10 to the power 3. Remember, kilo is a prefix. So to move from a kilojoules to a joules, this we multiply by 10 to the power 3, which is 1,000. Mathematical skills. We have to do what? We have to transpose. Why are we transposing? Because there is a plus there. Therefore, we have to transpose. So I'm going to end up with delta U is equals to 450 times 10 to the power 3 minus 275 times 10 to the power 3. The final answer is 175 kilojoules. Example 2. A cyclist does 5,000 joules of work to cycle up a hill. When he reaches the top of the hill, he discovers that his internal energy has decreased by 7,500 joules. Before we can answer the questions, can we break down what this statement is saying? The statement is saying a cyclist does 5,000 joules of work. So the cyclist is the system. And because it's the system, the work is going to be a positive. When he reaches the top of the hill, he discovers that his internal energy is delta U, has decreased. Something that when something decreases, we assign it a negative. So delta U is equals to negative 7,500 joules. 2.1. Calculate the amount of heat of the cyclist. From the formula sheet, Q is equals to delta U plus W. So they want us to calculate the Q. Negative 7,500 plus 5,500. And the final answer is going to be negative 2,500 joules. (2.2) Was heat given off or absorbed? Our answer is negative. So it means the heat was what? The heat was given off. 2.3. Explain your answer in 2.2. So the value of Q is negative. So this answer is not enough for 2 marks. So what else can we say besides that the value of Q is negative? Think about it and let's hear your thoughts on the comment section. Example 3. If 6,000 kilojoules of heat is supplied to a heat engine. What is a heat engine, by the way? A heat engine is a device that converts heat energy into mechanical work. You should be able to define it in an exam. So the heat that's being supplied, positive 6,000 kilojoules because it's being supplied. And an internal energy of the system increased. The internal energy delta U, it increased. So if something increases, it means it is positive by 2,500 kilojoules. Calculate the amount of work done. Q is equals to delta U plus W. Substitute the information. 6,000 delta U is 2,500. I did not convert the kilojoules because they're both the same. Plus W, we transpose 6,000 minus 2,500 is equals to W. Therefore, W will equals to 3,500 joules. The answer is positive, meaning the system is doing the work, so the work is positive. This question comes from Free State 2022 November paper 2 exam. It states that the diagram below shows the interchange of energy between the system and its surrounding. There is no exchange of matter, capital letters. There is no exchange of matter between the system and the surrounding. When you're given the diagram there, there's a surrounding in a block, system in a circle, heat arrow going in 1,500, and the work done arrow going out, which is 2,200 joules. Question 1. 3.1. Is the above mentioned system open or closed? This is no guesswork. You need to analyze what they said. They said what? Shows the interchange of energy between the system and its surrounding. But yet again, no matter is what? Is exchanged. So the only thing that is being exchanged here is the energy, but no matter. So the answer here is a closed system, because a closed system is a system that what? That only exchanges heat with the surrounding and no matter. Open system is a system that exchanges both matter and heat with the surrounding. And then an isolated system is a system that does not exchange matter or heat with the surrounding. You need to remember that. So 3.1, closed system. 3.2, it only exchanges heat with the surrounding and no matter. 3.3, define the following. May I please not write them down? 3.4, state the law of thermodynamics in words. Let's see if you remember it. If heat Q is added to a system, it can be used in two ways: in increasing the internal energy of the system and in doing work against external pressures. Let's use a diagram. We're saying we have a system and we are doing what? If heat is added to a system, it can be used in two ways. What way? In increasing the internal energy of the system and in doing work against what? Against external pressures. I'm not going to write the law down. I hope you know it now. 3.5. Use the information given in a diagram to calculate the internal energy of the system. Q is equals to delta U plus W. Whenever you hear internal energy, this is the formula you are going to use. So they're saying work is done by the system because the arrow is going out. And if it's done by the system, I know that the work is going to be positive. Heat is being added because the arrow is going in, and that means the heat is also positive. So I'm going to have 1500 is equals to delta U plus 2200 transpose. If you don't know your mathematical skills, you will be dividing here, which is not right. Delta U is equals to 1500 minus 2200, and what is the final answer? Negative 700 joules. .6. What conclusion can be made about the internal energy of the system based on the answer in question 3.5? Write down only increase or decrease. The answer is negative. So it means the internal energy did what? The internal energy decreased. Explain your answer in question 3.6. Remember what we said. We said that internal energy of a system can be decreased when what happens? The system is the one that is doing the work. Once the system does the work, the internal energy is going to decrease. And what do we know? Value of delta U is what? Is negative. Please make sure you know the following: working substance, heat engine, and thermodynamic variables. They like asking these questions. Please know them. When we speak of a working substance, we're saying it's a substance that absorbs heat from a source to perform a thermodynamic process. Examples of working substance: water or steam, petrol or diesel, air or refrigerant. So we know that a thermodynamic process involves heat. So it means these substances must be able to absorb heat and then perform the thermodynamic process. If heat is not involved, it is not a thermodynamic process. So if you take into consideration when you are hair drying your hair, when you're using your hair dryer, what is happening at the end of one end of your hair dryer? Cold air is coming in and it's being heated by the nichrome coils inside the hair dryer, and it comes out on the other side as hot air, which is going to do what? Which is going to dry your hair. So it means what? Air is a working substance. Another one is water. Water is used where? In steam engines. So water absorbs heat from a source and then it gets converted into steam that pushes the piston inside a heat engine, a steam engine, then moves it. So any substance that can absorb heat from a source to perform a thermodynamic process, it is a working substance. A heat engine is a device that converts heat energy into mechanical work. Straightforward. Thermodynamic variables or coordinates that influence the thermal state of a system. PVT, pressure, volume, temperature. Let's look at the heat engine, for example. Once the water starts to boil, what happens? The temperature of the water starts to increase. And as the temperature of the water starts to increase, what happens? Steam builds up. And once steam builds up, what happens? The volume is increasing. And the more the steam builds up, there's pressure that builds up within the engine. Hence, the piston is going to do what? It's going to move up. Once there is a release of the pressure, meaning some of the steam is escaping and there's a decrease in the volume, the piston is going to go down. Over and over again. This video was supposed to be short and sweet, but it seems very long. I hope you enjoyed it, and I think you're ready to cover the portion for hidden thermodynamics in your paper 2.